So, I'll take about 40 minutes of your time, maybe even less. So I'm trying always to be, more compact in order to give you opportunities to ask questions. So I'll have 14 slides. They're all small, and we'll start with the first one. So basically, what we do, we write code. It's a company. It's a small company still, and we write code. Like we, create software for our customers. So my first question for you is, who of you ever been a customer for software developers? Who ever ordered, programmers to write something for them? So that's great. So we'll speak the same language. So we write code. For customers, for our clients, it looks like traditional outsourcing. It may look like traditional outsourcing. So you have, the customer has some product to make. They come to us. We build the product for them. But the way we do it is absolutely different from everything else which exists in the world. That's my pitch. And I'll try to show and to prove it. So the final product is basically, it's usually a Java code, like some Java product, web service, web app, mobile app, that kind of stuff. So it's pretty traditional software. We're not doing something specific. We're just mainly in Java domain, and we're just creating the product. It's like everybody else. But these are the numbers which we have, so to show you that it's all real. So we have, over the last 18 months, it's a year and a half, we had real 8 paying customers, so they actually paid for this work. We completed, some of them completed, some not, 28 projects, commercial and open source. 132 programmers came through us. Some of them still working with us, some of them just gone and don't work with us. We paid for about 23,000 hours to these programmers. So that's an amount of money or effort contributed through us. We wrote about, I just counted it today, we wrote about 300,000 lines of code, and we have this metric which is called hits of code, about 1.5 million. It's not important just to give you a number that we're not small, so there is something to measure. We're not just experimenting. And so right now we have 50 programmers actively working, just actively contributing and working. And now the most important part is that all this stuff we're done, we don't use Slack, we don't use Skype, we don't use any emails, we don't use any phone calls, and no meetings. So during all these 18 months, working with that amount of people, creating that amount of code, we haven't had a single meeting. We haven't had a single conversation with any of these programmers. So I never talked to any of them. But I'm a programmer myself, I'm an architect, so I've been participating in all these projects myself. So I'm writing code as well, I'm charging my customers for my work as well. So I'm staying in this project as well. And no meetings, no phone calls, no chats, so they don't talk to each other. They don't even know each other. Personally. So they can't just, one of them cannot just ask something else from another one. There's no communication between them. So that's our pitch. That's why we're different from everybody else. And we're real, like I just showed you. So it's not just experimental. Even though I started to experiment with this 6 years ago, and for 4.5 years, I was just trying and experimenting and having problems and just trying, spending my money on this, getting nothing from the customers. And only the last 1.5 years, I'm actually making commercial projects. So I put it in the market. And I called it extremely distributed software development, because it's really extremely distributed, like I'm going to show it to you like in a few minutes, because people are working, all of these programmers, they sit in their own places, they are everywhere in the world, they are in different countries. We tried to calculate how many countries, it's over 20. We even had a programmer from Togo, which is a country, I didn't know about that, but yeah, so we have people from everywhere. Yeah, it's a country, yeah, I just learned it a few months ago that there is a country. And
isn't it in the Sandwich Islands?
I don't.
Oh, very good.
So I'm saying that there's people from everywhere. They're distributed. They don't communicate. So we don't have a central office. Even though I stay in Palo Alto, we have a small office in Silicon Valley, and we just have me and a few people helping me here. But this is only marketing and sales. So all our technical resources, all these programmers, they're everywhere in the world. Ukraine, Russia, Germany, a little bit of America, Canada, Brazil, Argentina, Australia, Togo, whatever, all different countries. We don't care where they're coming from. just as long as they can write code. And what's important to say that we work with senior developers only. So we tried to work with junior programmers, it just didn't work like well. So we focused on like senior guys who have good experience, who know what they're doing, and we pay them quite well. So an average price which we pay these developers, pay attention, we work only with individuals, the people who sit there at home and or in somewhere, but we don't have any middleman between us, so we don't pay any companies who pay programmers. So we pay them directly, and an average rate is about $30 an hour. Sometimes we pay $50, sometimes $60 an hour. So it's directly the money goes to programmer, which means these programmers are quite good. You can understand, even for Silicon Valley. Maybe for Silicon Valley these rates are not high, but for Togo or for Ukraine, this is quite high rate, like $50 an hour. So how do we do this? That's a question. How do we do how we don't have meetings, how we don't have this face-to-face communications, and how it all works? Tickets, that's an answer. So everything happens through tickets. So people work with individual tasks which are assigned to them through tickets. So the tickets actually is the vehicle on which we drive this whole thing. You probably understand what tickets is. So the ticket is like piece of the description of what needs to be done, maybe a bug somewhere or some description of a task, and then the person, the programmer, works on this ticket, talking in this ticket, communicating there, discussing there, but it all stays in one ticket. We're using GitHub also. Some people use Jira. Well, we are using GitHub because it's just very popular system, quite powerful and simple at the same time. So tickets is the mechanism for us to communicate with people and to organize all this stuff. And I made this picture to show you. Let's say we have two programmers, and the whole system, which is in the center of this picture, the whole system. We found a way, we found a mechanism of how to break down the big problem into smaller tasks, into smaller tickets, into smaller tasks, into smaller problems, and then to assign these problems to individuals, to programmers. So basically it looks like a mosaic. Do I say it right? Mosaic, yeah, mosaic, yeah. So it looks like a mosaic which in the beginning of the project it has a lot of white spaces there, and then when the project grows and grows, then these small elements gets filled by the stuff contributed by programmers. So when the Bruce's works on one ticket and Jennifer works on another ticket, they don't talk to each other. They communicate through this scope, through this code, and through the tickets. So each of them works on their specific problem and contributes their specific piece of result to the whole scope, staying isolated from each other. So they don't need to, well, they may, initially, sometimes they want to talk to each other, but I'll explain it a bit later, we prevent that, we prohibit these conversations, and we keep these people isolated so that they communicate through the code we produce, through the source code and through these tickets. So all communications stay in isolated tasks and in individual tickets. I'll get deeper into this. But did you like this picture?
Yeah.
Because I spent like an hour to make it.
It's good.
Yeah, that's kind of, to visually explain what it looks, because in some projects which take, for example, half a year, after half a year we have about like 1,500 tickets or 16, like up to 2,000 tickets. It's a huge amount of individual tasks, and each task gave something to the product. So it's like a big amount of conversations which happen in a very disciplined way. So it's not like discussions on a room, it's not like a discussion on the phone, it's every time it's a number, each ticket has a number, and under this number we have something going on. We have some conversation between sometimes some programmers, an architect, and then some code is being contributed, but we always stay in this single ticket. And then the ticket is closed and we jump to the next ticket. And now I'll show you three fundamental, not fundamental, but three important, let's say, principles, or number one. Now I'm getting to what actually is happening. All the before, it was just an introduction. So now we're getting close to how it works. The first thing is we have micro budgets. So every problem, every task we assign to a programmer has a fixed budget. So we pay them and the budget is fixed. And usually, and it's always small, like half an hour up to an hour. So all these tickets, each individual ticket has a fixed budget, which will be paid to the programmer when the problem is solved. So we basically break down the big scope into big amount of fixed size or fixed priced sub-projects. And each sub-project has a pretty clearly defined scope in this ticket and an attached price of how much money this programmer will get when the ticket is closed. So this is important. So programmers are extremely motivated by money. So they want to close these tickets, not because we pay them in the end of the month like traditional software development is doing. Not because we pay them by the end of the week, but we pay them when the problems are solved, like individual problems, small problems, these tickets. Some bug is solved, boom, the money goes there. Some feature is introduced, the money is paid. So we pay them when the problem is, when the ticket is closed. That's important. And we pay small amounts. So by paying them small amounts, we kind of prevent them from spending. So they're not supposed to spend too much time. They're not supposed to spend more time than we're paying them for. So we give them, let's say you have a ticket, this is your problem to solve, you have 1 hour to work on this problem, and you will be paid just for 1 hour. If your rate is $50 an hour, then this is the $50 you're gonna get when this ticket is closed. So if you spend 2 hours, you're still gonna get $50. If you spend a day on it, you still get $50. And this is what scares, in the beginning, new programmers when they come to us, because they are used to a less disciplined way of work, and they are used to be paid for whatever time they spend. In our case, there's a fixed scope problem and fixed scope budget. If they cannot complete, that's probably the question you may have now. What happens if the task is bigger? Like it's difficult sometimes to break down everything to such small tickets. That's true. Sometimes we give them a problem is bigger and the budget is still small. In this case, we encourage them, we teach them to do something, to do as much as possible for this budget, and return back the problem to the source code with some unsolved markers inside it. Like, let's say you need to introduce a big feature which will allow us to download a big document from our mobile app. I can't do it in 1 hour, but I can do something. I can introduce the possibility to just download an empty document. That's possible to do in 1 hour. So I'll do just that, and then I say to be completed, to be continued, not implemented yet, and put it back to the source code. I get the money for this small solution, for this small step ahead the bigger solution, and then these markers will be again converted to tasks which be given to other programmers. So it's kind of the programmers themselves create tasks for other programmers. We will discuss it probably. You will have questions about that later, I'm sure, but I'm just saying how it works technically. And these programmers work on many tasks in parallel. So each guy, when there are senior people working with us for many months, they work on parallel like 15, 20 tasks. So they have many tickets assigned to them, and they close these tickets when they have time. So our statistics tell us that approximately it takes about 4 days to solve a problem, to close a ticket which costs 1 hour or half an hour. So it takes 4 days. So they do something, then they return back the code, then there's the code review is happening, we'll discuss it now, and then another code review is happening, and then the technical check is happening, and then some feedback, something is wrong, and then some corrections, and then boom, finally the result gets into the source code. And that takes about 4 days. So they work in parallel on about 20 tasks and about 4 days to close each task. So you can imagine the amount of volume they have, amount of volume of work we put on these people. But that's micro budgets. That's first thing, which is important to digest for you, which is not traditional, which is not like everybody else is working, because I haven't seen it anywhere. So usually programmers are just working and working, doing something, and then we just pay them when they bill us. So, and then we don't control how they work, basically. They control us. So they tell us how much it's going to take, they tell us how much hours of work is going to be spent and everything. In our case, it's not like that. We know exactly the amount of tasks we're going to give them. We can predict the amount of tasks we will see in the future. We can calculate, and we control exactly each task, and we motivate these people by money. which is also not really typical for programmers, because usually, you know, programmers are being motivated. That's what the whole industry is telling us, that the programmers should not be motivated by money, they should be motivated by something else. I don't know by what, but many different things. In our case, we focus specifically on money. So you complete the task, we like your quality, we accept your code, this is your payment. And what's interesting, we pay them right after the task is completed. Not at the end of the month, not at the end of the week, but we make micro payments, like many payments a day. We use PayPal, we use Bitcoin, we use Upwork, so we use different platforms to make multiple micro payments a day. So good programmers, they receive from us like 5, 7 payments every day. So they are not just waiting for the end of the month, they are working like every day, working for money, contributing something, getting something back from us, which is also quite unusual, but it proves in our case that it actually works. That's first. Number 2, which is, there are 3 in total, so this is number 2, which is interesting to explain and to give you an understanding of how it works. It's called, I called it strict merges. I'm not sure how familiar you are with the software, how software is developed, but usually people work, there's a big piece of code which we have in the center, and then when I'm a programmer, I want to change something, I basically make a copy of this stuff for me, and then I change something here, and then I return you back the difference. And I'm saying, here's my difference. In GitHub, it's called pull request, so-called. So here's the difference, I just made my changes. Can you please put this difference to the main storage of code? And this procedure of putting back the stuff into the main storage, called merge. So we merge my changes to the main storage of code. And many people work in parallel. That's done. This approach is quite popular because it allows us to work in parallel. So many programmers can have their own copies of the repository, can make their own changes there, and then merge and merge and merge in parallel. So traditionally, again, we're different. Traditionally, people just, organizations, companies, they just allow programmers to get this stuff from their own copies, like I just explained, and put it there by themselves. So I'm a programmer, you give me something to work on, I make these changes here, I think I'm ready, and I put it back myself. I just put it back, In our case, our quality bar is way higher than traditional development, and we do not allow programmers to put their stuff back unless the changes pass a huge amount of quality controls. Again, not sure how technical you guys are, but we have static analysis, unit test code coverage, we have 2 code reviews, one by the peer programmer, one by the architect. So it's a number of steps which me as a programmer, I have to pass before my code will actually be in the main storage. So it's difficult. My point is that it's difficult for our programmers to put their stuff back into main storage. It's difficult on one side, and we pay only when it's there. So we kind of create a conflict. So the programmer's interested financially to put the code back into main storage. But it's difficult to do because the quality bar, the requirements for the quality are very high. So the good programmers, they finally manage to fight with these quality requirements, and they finally manage to push eventually their stuff goes into the main storage. And by using this conflict of money and quality control, we achieve an extremely high quality of the product in the end. So in the end, this main product, which is here, is, according to our analysis and according to the feedback from our customers, the quality of code we create is extremely, it's way higher than any other company, any other group of programmers can create. Just because of these 2 things. First of all, we motivate by money, and second, we don't allow you to complete unless your code is perfect. That's it. In a traditional development model, it's not possible because programmers just sit in the office, they get their money in the end of the month, and you basically cannot force them to do high quality because they will find a huge amount of excuses. Like, I can't write this unit test because I have to go home now, my train is there, I have to catch a train, how about we do it tomorrow? In our case, we don't care about the trains, we just don't pay you.
Right.
There's no unit test, we don't care about your train. Okay, come back tomorrow, and until the unit test is there, your code will not be accepted and you're not going to get the money. That $50 will stay with us, not with you. And we don't hear any excuses from programmers. We don't care about their vacations, the trains they have to catch, the problems they have, something is not configured, they don't know how to write the unit test, they don't have enough information, literature, configuration, the computer is dead. We don't care about all of this. Because we only accept the final result and we pay for it. That's it. So that's why I'm saying, that's why I'm paying attention to the strict merges. So we are very strict in merging this stuff back. And yeah, so that's number 2. And number 3, know the school. We call it know the school. Yeah, that's very, again, when new programmers come to us from their traditional model of work, where they work, we have people, in most cases, I didn't say that in the beginning, but in most cases, we work with people who are full-time programmers somewhere else. So they work with us as part-time programmers. I don't think we have anybody who would work, I don't actually know that for sure, but I don't think anybody work with us full-time. So all of them, they are somewhere. We have people from Oracle, we have people from Luxoft, we have people from EPAM, so we have people from outsourcing companies and small startups everywhere. They work somewhere, they get full-time salaries, and they work with us part-time, in the evening or in their office time, I don't care. But when they come to us, they used to do what they know how to do in their traditional companies. And these technical people, they used to work in an environment which looks like a school. If I don't know something, I'm going to ask my colleague sitting next to me. If I don't know how this project works, I'm the first-time programmer, I just enter the project, I spend, how it works, like first month just to figure out what's going on. You hire a new programmer, and in a few months you can't get any results from this guy because he's just figuring out what's going on. He's going around asking how this works, tell me about this project more, I need to understand how the database is organized. So they are learning about the product. It works like a school. So they are learning, and we're paying for this learning. In our case, it's completely removed this part. We're not paying for learning at all. We are not using the money of our customers to educate our programmers. So there is $0 spent on education. You come to us, something is not clear, just file a bug, say that I don't understand how this project works, and then we fix our documentation and make it better for you. While we are fixing, you just wait. Don't do anything, just do something else. When the problem is fixed, you come back again, you check the product again, and then if everything is clear, you start working with it. So we are spending money on improving the product, not making our programmers smarter. So the traditional approach is that people who order this, customers, they depend on the knowledgeable programmers. They need to have people who know how the product works, and then these people can continue to improve it and make it better. In our case, we can remove all programmers from the project, and bring the new team of new 20 people, and they will start the next day. They will have all the information there because the information is in the code. So the code itself is so clear that new people who come in, and we usually we put people in the project, we remove people. The product itself becomes a documentation, becomes a source of information for everybody who is there. So we are strongly against this knowledge experts. We are strongly against people who know more than an average programmer should know in order to write something in this product. So we are moving people from project to project because, like I'm saying, this is not a school, so we are spending the money of the customer to make the product better, not to make people more educated. That's again a fundamental difference from what everybody else is doing. And we keep people, that's what I want to say, we keep people isolated, like on that picture, so they're working in isolation, and we prevent any communication between them, so we do not allow them technically to have any chats or conversations or emails. So they are kind of, starting in isolation, continuing in isolation. They have to use, the only source of information they have is the source code. It's the source code and tickets and the documentation. So there's electronic sources of information. They cannot ask anybody because there is no anybody around. So if something is not clear in the code, they just submit a bug and say fix the documentation. When the documentation is fixed, we improve the product, and then they continue. So yeah, the summary line here is the project is the source of information, not people. So there is nobody to ask around. There's nobody to get details of how it works. The only source of information is you open your code, look at it, you should understand it, even if you started just now. Okay, we have 10 more minutes, and I'm gonna answer the main question now. Why it should be interesting for you as a potential, I'm not trying to sell it now, but still, I want to answer this question. So why it's interesting for the customer, for somebody who has the money and wants to create some software? You can come to us, to this model, or you can go to another outsourcing company. Yeah. So the main question is why? And I have you give the answer, and then we'll finish. So the answer is ROI, return on investment. So I believe, and I see, and that's what I experience, is that in our case, the return on investment is way higher. So the money being used way more effectively, and I broke it down into two aspects, actually. The first one, this whole solution is cost effective. Cost effective when we are building the product. So we're not saying we're cheap. We're definitely not cheap, because we are getting, like I said, we're charging $50 for $40, for example, for an hour of programmer for this task, and we charge the same amount on top as our commission. So we are, the programmer in the end will look like $80 an hour, or $10 or $100 an hour for you as a customer. But if you look at the outcome of this money, of how much results is produced for this $100, then you will see that I made this calculation. I wrote an article on my blog about it with the detailed comparison, and I took one ticket from one of our projects and showed how much money were spent on that, and demonstrated how much results were produced. So this is the numbers. So we spent it was one ticket, one problem. It's public information, it's an open source, so it's possible to check. So we spent about 2 hours of time, and 5 people were participating in this. One person reported the bug, except there's something wrong. We paid him for reporting the bug. We paid for that too. The second person was the person who actually made the fix, like fixed the stuff and contributed the code. Another one was the code reviewer. So another person who jumped in and said, okay, you have the problems, please fix here and there, and only then I will accept your code. And then it was 1, 2, 3. Person number 4 was the architect, who also did the code review after the peer review. The architect also took a look and saw what's going on. And then we merged this stuff, and then another person, one more, did the quality assurance in terms of checking how, not the quality, not the testing, but to check how it was organized and whether we actually followed the policy of work. It was 5 people, and we spent 2 hours totally paid to these 5 people. Some of them get like 20 minutes, one of them get 15, somebody get 40. So in total it was 115 minutes, so almost 2 hours. And we paid about $100, because for 2 hours we pay, an average price is $25 for the person, and plus our commission, which means $50 an hour, 2 hours, $100. And then the question is, we, using $100, we organized 5 people to create a feature which took like 5 files were changed, it was twice code reviewed, it was merged, so it's a long process. It's not possible in a traditional team, in a traditional organized team, for $100 to do the same amount of work. You cannot just put 5 people together and they will produce 8 tickets every day, for 1 hour, because they will work 8 hours each, so we can assume that they should produce 8 tickets, complete 8 tickets every day, this team. It's not possible. They will barely complete 2, 3 problems, 2, 3 tickets like this. So we are using the same $100, we are 2, 3 times more effective. That's what I'm saying, ROI. So for the return for the investment is way higher, because the amount of product we deliver is way higher. Why? Because of the things I explained before. Because we pay for results only, we control quality much higher, so we demand much more from programmers. We work only with senior people. So all this stuff, and we organize them like not in a school, so they don't spend any time on meetings and discussions. In these $100, nothing was wasted on coffee breaks, on lunches, on vacations. It was just the $100 spent on just results. In a traditional team, it's not possible. You will definitely pay for the time which they spend on top of actually writing code. So that's the first reason. It's really cost effective. it's not cheap. Sometimes it's expensive. Sometimes we have people for $100 an hour, and we put our margin on top of that, which means $200 an hour. But in the end, the amount of product we deliver is way bigger. That's what makes us really different, and that's why ROI is higher. And the slide before the last one is maintainability. So the code which we produce is way more maintainable. It's extremely more maintainable than any other team can produce. Because there is not a school, because there is no money spent on educating people, all the money are spent on the code itself. Which means that we can easily, like I just said, we can easily remove almost everybody from the team, maybe even sometimes everybody, and put a new team there, and they will just immediately understand how it's all organized. Because everybody who worked there, these people were not able to communicate with anybody. Nobody taught them anything. They learned everything from this code. If they learn it from there, then other people will also learn from there. And another thing is that the diversity is quite high. It means that people are coming from everywhere. They are from different countries, they speak different languages, they have different cultures of development, and we don't have any get-together meetings. So we're not trying to, like this very popular in the agile world, the problem is how to put together these cultural differences and how to make my effective team in America and in Ukraine work together. That's a big problem. Let's fly to Ukraine and spend some time there. I've heard it so many times. Let's fly to India and live there because we need to understand their culture. We don't care about culture at all. All these people, they're coming from, like I said, the Togo, the Ukraine, we don't care where it is. We only care about the code they produce. So we don't even know are they male or female. Sometimes we have girls working with us and we only find out that they're girls because the icon in the GitHub. So we don't really, that's a real situation. So we don't really know who they are. We don't care about cultural differences. We just look at the results they produce, and the diversity is quite high because of that. So it means that the result is very maintainable. If such a big team, and a normal average team takes about 20 people in our case, like 20 or more, that's the average team which works on a quite average small project. So if 20 people from different countries were able to work on this piece of code for quite a long time, coming and going, rotating, then it definitely means that this code is maintainable. It's way more maintainable than the same code staying in the hands of 3 programmers sitting in the same room for a year. You fire these 3 programmers, you're lost. You don't have a code anymore. Because only these 3 people knew actually how to deploy this stuff to the server, how to actually install a new version, how to upgrade something, how to change the password. Only these 3 guys knew that. You fire them, you lose everything. In our case, we fire everybody, we find new people, you lose nothing. Because they didn't have any information in their hands. Everything was in the project. And it's not because we don't like people being knowledgeable. This is just practical. And the people who work with us, they respect that and appreciate that approach. And they understand that the goal of a good developer and a good architect is to become replaceable. A good architect is invisible in the project. A good programmer is replaceable. So these knowledge experts is a bad thing in general. So being a knowledgeable person and knowing everything, and it's good for job security, but bad for maintainability. Yeah. And one more thing which is also helpful for maintainability is that the tickets. So we discuss everything in tickets, we communicate only in tickets, and all these discussions, they stay with the project. So when you join the project after a year of work, you can see everything which we discussed over a year. If we would have phone calls or meetings, this information is lost. In our case, no meetings, no phone calls, all discussions are in tickets. I joined the project, there are 2,000 tickets. I can go back and back and back and see what these people discussed 2 years ago or a year ago, and why did they came to the conclusion that this particular line of code has to be there. So the summary line here is that the code is the king, not people but code. So the product is the king, not me, not programmers, but the code. So that was my last slide. So if it's interesting to try it, basically this is the name of a company which practices this approach. So XDSD is a methodology, is a theoretical thing. So if it's interesting to practice, this is us. You can hire us, you can try, you can see. I'm telling it for the camera as well. And that's how it works. Like I said, we are young. We're just a year and a half. We're just starting and trying. We're self-funded and profitable now. So customers are paying for all of this. We're not having we haven't raised any investments or anything. But we're planning to make it big. We're planning to change the industry. So the goal is not just to make money, but to change the way programmers work. I believe that this way of work, this extremely distributed development, is better than agile. It's better than what we have now. This is the future. That's it. Thank you, and now your questions. Let's start from there. Yeah, but
Okay.
then yeah.
So I think I really like that approach, and I think it solves a lot of issues definitely. What I'm not clear is that typically any project starts with a kind of an architect, designing the architecture of whatever you want to design. Is this part of that project? Because I don't see how that piece or where that piece is fit in that picture. That
What is the overall
described.
That's a good question. Yeah, it's a good question. So I repeat the question. So the question is it possible to design an architecture approaching it in small pieces? The answer is no. So we try to do it, but it doesn't work. So that when we start a project, it's a good question. When we start a project, we get an architect there, and we give this architect some amount of time of free time, like 40 hours, just work on it. And then the architect come back in 5 days, bringing us the skeleton, the working skeleton, and then we continue in this ticket. So yes.
Who pays for the architect?
For the architect, the customer pays, yeah. But that's only just selected people who we trust, so we understand that these people are not gonna, well, they work with us for years, well, for a few years. So we just have like 5 people like this. And these people, they get to start, they have to start. So of course, we cannot start with just tickets and small changes because there is nothing. So we need a skeleton.
Do you discuss what architect comes with? Do you discuss, like, you send the task to architect, he works, he comes back, do you discuss what he did?
Yeah, of course, yeah.
So
He
you
brings,
still have this meeting and discussions, right?
in the beginning, the architect, in the beginning, and just the first step of the project, we have just not the meetings. We still don't like have meetings, but it's in GitHub, but it's in writing. So the architect brings back some solution, and he explains it to me. Like usually, I review what the architect has done, or another architect. So we have 2 architects usually in the project. One is creating the skeleton, another one is doing the review. And when they agree that it's good, it's not just the code; it's also documentation of why I made these decisions. Why I decided to go for MySQL instead of Oracle, why I decided to do it this way and instead of this way. So this is documented, and then we bring it back, we approve it, done, and then we run.
What if you don't like what architect comes with?
It happened only once. We just changed the architects, threw it away, and then start from scratch.
But
Yeah,
you-
it's
You're paying to architect by traditional.
the architect we pay traditionally, yeah. Just the amount of time, just report how much you spend, and we pay.
I know, I have to.
Yeah, sorry.
Very interesting. I've dreamed many times of just sitting in isolation and not talking to anyone. I mean, I'm not joking. I seriously, I love that idea. But sort of along the same lines, I think you're going to get a lot of questions. The notion that you can't Scrum board architecture or Kanban it, right? That you need to have some supporting functionality in terms of not just architects, but a product manager, a product designer. Testing is not unit testing, it's integration testing. That's the hard part, right? And that's the hard part of merging and doing all these. Somebody needs to write, your developers can write your unit tests, but somebody writing integration tests is a lot more tricky. Starting off with a project with a blank slate. So if you come in and you have an existing thing with 5,000 bugs in it, absolutely break it up into this. How does that work? How do these extra layers come into play? And how can the microtasking? How does this
In
come
the
into
beginning,
being?
it's a little bit more difficult when the project just starts
Yeah,
to run,
that's
because
exactly it,
we
right.
just have like 5 tasks or 5 tickets. It's not enough. But you're right. When the project is running and we have like a few hundred tickets already, it's all like smooth and we're just running and running. But when we start, it's a little bit more difficult. So it takes some time to. When we start slow. So in the beginning, it's always slow, like 1 ticket a day, 2 tickets a day. That's how much we close. Just ticket, and then these tickets produce more. The integration tests, they're also written by programmers. So everything they write, everything is done by programmers. But when we start, it's just slow. It's just way slower than when in the middle of the project. Did I answer the question?
Kind of.
Yeah, I'll probably get back to it in a minute. Yeah, sorry. Let's start.
How much is the largest project that you run this way?
Large in terms of time or amount of code or money?
Any metrics you want to put on?
Well, the largest one is, the biggest one is about a year in duration. In terms of code, in terms of size of a team, it's about, like I said, 20 people, 20 programmers. They're good programmers. In terms of amount of code lines, it's about like 70,000 lines of code. It's a Java product. It's a big data analysis, big data manipulation, quite intensively using
How
big.
many lines of code is it?
70, yeah, 70,000. It's not huge,
20
yeah.
people?
Yeah,
And you
20
think-
people.
You're saying that you have a high productivity?
They're not working full time. It's not full time people. So
Right.
they,
Okay, so
whenever they
then
want.
can you say it's in, rather than number of people, what's man hours?
The number of hours.
yeah, I can say number of hours. Yeah, in terms of number of hours, I would say. So we calculate how much money we spend for the line of code, if that metric will give you something. But that's approximately, in our case, approximately 90 cents per line of code, if it tells you something. But we calculate these metrics. Yeah.
All right. And if I may, you said that you don't pay for schooling, for
Yeah.
learning. Pardon me, but on the surface of it, it sounds totally absurd. How can you bring a new person on a project that runs for 6 months and not to give him any time to learn what's about? How can he work?
That's a good question. So first of all, we don't want this person to learn. We want this person to solve problems.
But does he need to read your tickets? Does he need
Ticket.
to read it?
Ticket
What
or
is- what
2-3
difference
tickets
does it
or
make?
4.
He needs to learn what the project is about. You're saying you have a particular form of a description.
Yeah.
Your description is the code and the documentation.
Mhm.
Well, everything believe that that's right.
Yeah. So when
But the person needs to read the damn thing. He cannot take it.
let's
by
say you're a
osmosis,
programmer.
right?
Let's say you're a programmer. You
Right.
come to us. We have a project. It runs for a year. So it's like it works. Everything is like a lot of. It's happening right now. You came to us and we say to you, this is your ticket number 1, the ticket number 773. You have to solve it. You have half an hour. We're gonna pay you $25 when you solve it. You open the ticket. You see the description. Like the class number A doesn't work as it's supposed to be. We need to fix it and make it sure that it works. Don't forget to write the unit test. That's a description. You start. You check out this class A. You look at it. For example, just give an example. First example, you look at it, you understand by the definition of the class, that's clear, it doesn't work because this and that. You fix that, you create a unit test, you commit it back. You don't care about the rest of the class, you just fix it.
But somebody need to reduce the task to a particular
Yes,
class.
it
A,
was
right?
created
So
by somebody else
was
before,
supposed
yeah.
to really look into understanding of what
Of course,
the
yeah, before
problem
somebody
appears
created
in
that for you. Yeah, the task was created by somebody else before you joined before you joined the project.
But isn't it faster than to fix it rather than to explain it to somebody else and try to take it? After you've done all the work and you understand what the problem is and how to fix it.
Yes, and then this information stays in your head.
Right.
No, documentation, I agree completely. A good quality documentation is essential, and that's essential to be able to transfer this knowledge. My problem with it is that you're saying you don't need any, you're not paying for people to learn
Yes.
what the project is all about.
Mhm.
Then you're basically saying you turn programmers into ants, pardon me.
No.
That's
Pay
what you
for
do. There is
results.
somebody.
What's wrong
there
with
is
that?
somebody
They
who's-
pay for results.
well,
But
maybe
there's still
well,
some
there are plenty of
mechanisms,
wrong
of
with it,
course,
but
right?
that's a different story. The point is, somebody needs to understand what the product is about.
We have
You
an
started-
architect.
you
In
started
each
with
project we have an
the point
architect.
that you write code.
We have an architect, yeah. in each
Nobody
project.
writes codes, we produce products,
But
right?
it may be
Think about
a
it as
one-on-one
think about it as
discussion with
construction.
people.
Right, well,
Somebody
let's
lays
take this
a fixed
offline,
out,
because
you
it sounds
just
more
go
like a
with it.
political discussion than a business
All right.
discussion.
No, it's a good question. It's a good question. We'll get back to it in a minute. Yeah.
Well, we can also get into what motivates programmers, and the fact that it's money, it certainly is, but it's not just money.
Yeah.
As much of a capitalist as I am, and it took me a long time to realize that, but it's not.
In our case, 1 second. In our case, we start with money, but in the end, when it all works and programmers comes and see how disciplined we are and how different we are from everybody else, money becomes, I think, the second motivator.
Right.
They are motivated by staying in the team, which is extremely disciplined and doing
Right.
something very high quality.
Right.
So they just love to work. People come to me like I'm getting like 5 resumes every day, and 20% of them just coming and saying, I just want to work with you, doesn't matter how much you pay me. So they just want to be in the team, which is doing something so disciplined and so high quality. So the money it becomes a second motivator. In the beginning, it's the first, when the people just come in. But when they stay with us, they really enjoy doing that.
Okay,
And they are not like monkeys, they're not like ants. They feel that we respect them, we respect their results, we respect their contribution, and we don't expect them to be slaves and just work on everything. We want them to work on specific amount of tasks, get us the results, and get the money equal. We are equal with them. The traditional programming approach, when the people sitting in the office, it's more like modern slavery. I have these articles about that. So we just think that these people owe us something, and we basically exploit them and we use them and use their time. We're not equally paying them. In our case, we're equal. We, the company, the project, and these people, we're the same. So this is philosophical question,
Right,
but
it's,
yeah.
they're all gonna be philosophical.
Yeah, we have a question here.
Yeah, I happen to have like a traditional company, you know, like the one that it sounds to me like a dream. I have like over 120 full-time engineers that working, and I'm paying for their vacations and the elevator and the cigarette break and everything. Yeah, and this looked to me like a dream. But I looked in your website and it says, do you want to apply XDSD in your project? Hire Team.io.
Yeah.
Right.
So it's only your thing, or it's like in the methodology that you want also to teach other companies like myself?
Good question. Right now, this is just my company. We're just applying this methodology. It's still not finished. We're still experimenting and improving. Next year, we are planning to come to companies like yours and move this methodology to you. So instead of working through us, you will be able to do exactly the same with your programmers. So that's our plan. That's our strategy. So for now, it's just us.
So for now, I should just need to wait.
Or wait or come to us and hire us. Yeah. But or wait.
What
Yeah.
if I have the
Yeah,
time
you
and
buy
5
yours.
years to work?
Just
Sorry,
get
do
them
we
budget.
Yeah, we have a
violate
question
things,
here.
Otherwise
Yeah.
it becomes
Yeah,
chaos.
go ahead.
Right.
So, on a large scale, I don't see this any differently to the way the programming should be in a well-organized, well-documented, and well-managed startup. But what I wonder in your case, so if you have a ticket, how does it get assigned to people? If developers pay for the completion of the ticket, will they rush towards the lower kind of estimated ticket so that they can buck the ticket quickly, and then the more complex tickets will not
That's a
be
good
picked
question,
up?
yeah.
And how do you guarantee that the person who picked up
Yeah,
the
it's a good
ticket
question.
completes it?
I didn't cover it in the presentation. So that's another thing which makes our code more maintainable. We assign tasks randomly. So if you, the programmer, you worked on some piece of code, you almost finished it, and then you left some pieces which says like we need to finish it later. It comes back to me, and then we randomly assign it to somebody else. So your code will be now somebody else will work with your code. Open it again, understand what it's about, and fix the situation. So we just randomly threw our pieces of code to different programmers, and we never keep anybody on the same piece of code. So, and we don't allow programmers to choose tasks. So we just tell them, okay, this is your task now, work on it. If you don't like it, you can reject it. And you can say, I don't want to work with this task, give it to somebody else. That's possible. But it happens in 10% of cases. So usually people just accept it, and if something which is completely out of their area of expertise, they just say, I don't like it, it happens, but rarely. Probably this question, sorry. Yeah, that's it.
Actually, few points rather than a question. First, you're probably not surprised that you don't have any full-time developers. You already mentioned that it's people who have some other sucker paying for their cigarettes and so on, and
Yes.
they're making big bucks on it. Because frankly, as a former developer, I cannot imagine I will work 8 hours a day using the system. Okay? It's a one problem. So it may be good for some project, and probably by numbers you mentioned it's not a big project, and especially a project that not require 8 hours of work. You could extend 70,000 lines of code for 12 months development. It means that your customer is not in a hurry. He probably needs a good code, but not tomorrow. Okay? Second problem, which I see, and I certainly commented on this, that your developer goal to close very small tasks. So he's not spending thoughts and planning for long-term goals. Usually when you developer, you moving slowly, eventually you're moving faster because you're thinking about, okay, how I maintain this code? Will this code be reusable? In your case, it's not the goal of the developer, his goal to close the bug. Reuse of this class for future is not his concern, because randomly it will be assigned to someone else.
Yes, I'll answer. Yeah, answer the first question. I philosophically believe that working 8 hours a day for a programmer it's completely wrong. It's just not possible to write productively for 8 hours. 3 hours, 4 hours maximum, top. That's the amount of time I can write like effectively the code, like write, intensively write. So why do we need programmers to work 8 hours in general, in the future? Let's think 20 hours ahead, 20 years ahead. We need programmers who spend like 2, 3, 4, maybe maximum 4 hours a day, and the rest of the time just spending time with their families.
Right.
But they need to be well paid for this intensive use of their time. Just pay them $200 an hour, and they will just work 3 hours, do it disciplined way, contribute effectively, and go back to their families. That's it.
Good
So
point.
that's my answer. Answer to the second question.
Surgeon.
Answer to the second question. So you're saying that they're not.
Your goal is a small task to close this task is not.
Yeah, I got the question. I got the question. Yeah. So the second question is that you were saying that I'm a programmer. I get the task. I just finished this task, and I don't care about the product in general. So where are we going to get the information from programmers about the future of this product, of what can be improved, or how we can make it better?
No, not just this. You know, when I developed myself, I think I could write quick and dirty.
Mhm.
I could put some class, put more effort to development slot, but I will reuse it next month when we have a new feature or whatever. Code reusability. In your case, code reusability not add value for developer.
Well, it's a value for an architect. So you create something which is not going to be reusable, the architect will just reject
But
you.
you cannot define in task or ticket in terms fix this problem.
Yeah, but when you're fixing, we will ask you to do it the right way. So there will be 2 people who will look at your code and they will say, hey, this is not going to be reusable, do it the right way, do it better. So it's not just machines involved, there are people involved. So these people will definitely give you
Programmer
feedback.
doesn't know who the
But
architect
it's
is.
random people.
Yeah, random people, yes.
Can I challenge the first part? You
Yeah.
said that programmer is working 3-4 hours a day.
Mhm.
This is correct. I agree. I also code every day. Today I coded like 4 hours, and it's like
And that's
I
it,
agree.
yeah.
But I'm not only working when I'm coding. The best part is when I'm not coding. I'm going now outside. I'm having my coffee, and then I say, oh, why I did this before, and it's happened to me today. Yeah.
Mhm.
So the time that I was the most effective is wasn't the time that I really code. It was the time that I went out. And-
No,
and
you
I
don't
had
get
things-
there.
It's an
yeah.
eBay.
The difference
Saying I'll
problem
give you
was
$1,000 if you
not
solve the
separate
math's last
architecture
theorem.
and implementation.
No, it's-
He's talking about.
No, I'm talking about small problems that I did
Yeah,
today.
absolutely.
Small coding problems, not architecture.
Yeah, I agree.
So I don't think I just challenge you. You're saying that a programmer has to be 3-4 hours, and then the rest will be the family. Because when I'm with the family, I don't think of the code. But when I'm sitting and I'm in the environment of work and this,
I'll give you a solution,
Yeah.
how we solve this. I understand I understand what you're saying. We pay people for submitting bugs. So we encourage them to tell us what's wrong with the product.
yeah.
So we pay for the code you create and for the bugs you create. I mean, for the bugs you describe. So you are.
I understand.
So you work for 3 hours, you contribute some code, and then you're sitting and thinking, and hey, how about we fix this? How about we do it a little bit different? You just go to the ticketing system and submit a bug, saying, hey guys, I was thinking on the beach, saying, and you know what, drinking my cocktail, and then just found out that we need to do it a bit differently. Boom, you get the money for that. So we also pay for thinking, but in disciplined, organized way. We don't pay for you thinking and then we just don't know. Where are you thinking or not?
Right. So it's actually the same thing.
So
but
we need
just in
results.
discipline.
We need
Right.
results, yeah.
Right.
Results of thinking, results of code writing.
Can I?
Yes.
All right, so what does the agreement look like by and between the corporation that's contracting with Teamed.io and?
So between the customer and
Right,
us.
right, if you're hired.
Yeah, if I'm
Kind
hired,
of
yeah. So we just basically the
performance.
contract is very
Let me
easy.
finish
So
the
we just
question.
we just get the money from you, and we pay this money to programmers. And when we pay to programmers, we just put the top, we put
What
the
kind
margin.
of warranty
getting
and
a price?
guarantee do you have on?
There is no guarantee, nothing. So we
Okay.
just openly disclose you how it's managed.
Okay.
You see everything. You know all programmers. You see the whole process. You see everything. You know how it works. And all the money which we spend on them, you just
Right.
pay us. We transfer to them. That's
Right,
it.
right, so
we
you're
don't-
the Airbnb
Like
of.
yeah, you
of
can say
100
Airbnb.
We call
yeah.
them 100Xers.
Or
They're
Uber, yeah.
100 times
Yeah.
better than any program.
Yeah.
in the
But
world.
are you
providing some estimate of it?
Yes, we do. Every week we estimate the project and show you the numbers, how much we think this product will cost in general. So we do a lot of management on top of this. We give you the schedule, we give you milestones, we give you management information, but we don't charge for that. We charge only for results delivered.
Who's doing that?
We have project managers and our software.
And where's Patrick Boyle?
It's
It's
full
not-
time.
Yeah, it's not full time. It's also part time. Not full time, but people paid by results.
But
It's a layer on top of programmers.
Project managers is the part of this process. I mean, it also breaks into small pieces and paid by hours.
Yeah. Exactly the same. Yeah. No, I mean for project management we pay a little bit differently, but we're paying from our cut. So we just show you how much we pay to programmers, and then on top of this, the same amount we spread it out
And
over.
customers communicates only with project manager.
No, the customers. You as a customer, you stay together. You stay in the team. You see everybody. You talk to any programmers in the GitHub. So you can drive. You can jump into the ticket. You can contribute there. You can say, hey guys, I don't like what you're doing here. How about we change the direction? So the customer is actively participating in the environment. Sorry, we have a question there. Yeah. Sorry.
When you were talking about that we're not here to school them, and
Yeah.
so I pushed the ticket back saying I can't understand how this works. Now it needs to be documented. Who's doing the documentation?
Some other programmer.
So you open another ticket
Yeah.
that says.
You open another ticket. Yeah.
Please.
Let's say I'm a programmer. I get a ticket, and the ticket says you need to fix this
And
bug in
that
this place.
programmer could figure it out,
I-
what the first one couldn't?
No, I'm giving an example.
Yeah.
I'm a programmer. I get this. I'm gonna get the ticket. The ticket says fix this bug. I open the code. I have no idea how to fix this bug because the code is not properly documented. I'm saying I'm not gonna work with this for now. I submit another ticket and say, hey, could you please fix this to make it? I mean, could you please prepare it for me to make it understandable? And I'm sitting waiting. I'm doing nothing. I mean, I'm doing something else. And then you are assigned to this ticket. Now you have to get this piece of code, make it cleaner for me, not fix my problem, which I'm assigned to, but make it cleaner, and then return back to me and say, now it's good, look at it. I look at it and say, well, yeah, it's good. I close, you get the money, and I start again.
What
Well,
if
with-
he
if
You
says I
said you
don't
do
know how to
assign them
fix
randomly.
it?
Well,
How do you know
that's-
that the next
how
one
did
will
it
do
get to-
anything different than submit the same ticket again?
Yeah, I'm sorry, but how did it get to be such a mess if it went through the whole process? How did it, if it went through the review process and all of these checks that you're talking about, how did it get through that now I have to?
Well,
go
we're
back
all
to
human,
the
we make mistakes, a lot of bugs in our code, a lot of problems. We cannot guarantee that everything is clean, which is
Okay, like, one question is,
Yeah.
if you could describe a little bit more detail the type of, development you've done, your type of systems. The second question related to that, I can understand how the coding model works.
Mhm.
What you haven't covered at all was, okay, we're done coding, delivery, how does delivery work, how does deployment work? Those things that mechanically take more than half an hour, just because they do. Deployment and troubleshooting, mechanically those are actions that, if you deliver to me something that you told me, now I need to find somebody to figure out why this service is not starting, that probably would have been the last time I would hire you, right? Because there are urgency and time issues that I need a package I know works, and then what's the support model afterwards, right? You gave me code, I'm running that in production, what happens then? Because that's a model that involves security, involves access controls, involves access to data. So what I'm trying to understand, how actually the entire life cycle works. I understand the coding, I understand the architecture, actually, taking something, chopping into small pieces, and then some people are picking that up. It's okay for that space. There's way more to software development than just that.
Yeah, you got DevOps.
Yeah, the entire life cycle.
Yeah, I got the question. So to answer the first question, what type of systems we work on? Well, so far it's just a year and a half, so we just don't have experience, a lot of experience. Yeah, but we have web systems, we have big data libraries, and we have mobile apps.
Can you talk about any
So
of that?
mobile libraries and data, they're just at the end of the day standalone things. They're
Yes,
simple.
quite standalone. Yeah.
When
Well,
you
they're not
say-
simple. They're quite some of them quite complex, but they're standalone.
Standalone package
Yeah.
that gets delivered, much simpler than delivering a fully distributed systems that has to be deployed to the system, work with the system.
I understand. Yeah. So first of all, we don't just have a lot of experience, but to answer the same question, I didn't cover.
Your
I-
approach to the model. How
I
does the
didn't
model
cover it at all in the presentation because it's quite technical, but we pay a lot of attention to continuous delivery, which you just mentioned. So when we start a project, we configure it the way that everything is delivered in one click. So when the architect is creating the skeleton, this MVP, not the MVP, but the skeleton, which the architect starts with, The most important thing for the architect to create is to make sure that this whole solution is continuously delivered in one click. So we just hit the button and everything is packaged, tested, configured, and then deployed to production. And in production, and to testing, to staging, testing, production, everything. So all of this we configure when we start a project. And then when the project moves on, we deliver after each small ticket.
So that's good if you have 10 boxes. If you have 1,000 hosts,
I don't know, we
That's
we
a
don't
much
have,
bigger-
we don't have experience with 1,000 boxes.
So smaller scale.
Well, so far, yes.
Yeah, like Google wouldn't hire you, for example.
Well, I haven't talked to Google yet, but it depends. Well, of course,
So
right now
yes.
I'm not ready for 1,000
No,
boxes.
no,
let me
yeah.
answer the question this way: how do you see this evolving towards that? Because I can see how something like what you described works on a small scale. It won't fit in 40-hour effort to build a shell that can scale into that kind of thing. That's what I'm. Because there's a lot more than just code and continuous.
Yeah, the answer is here is that I, in general, believe, again, it's my technical belief, is that projects must be small. So if the project is huge, then it's a problem with the architect, and it has to be broken down into pieces. So no matter how big is the problem you're solving, if you're building Google, it's still 1,000 of small projects. So you still can make it 1,000 components, each of them deployed individually, tested individually, controlled individually, and then you can combine them into bigger components, and then you can combine them into bigger. So having something huge like Facebook is proud of telling everybody that their repository in Git is 50 gigabytes, they should be ashamed of that. So they're just saying we are so huge, our code is so big that the repository is 50 gigabytes. It's basically, it's a shame to their architecture. It shouldn't be like that. The repository has to be small, and then you have to have a combination, a collection of small repositories instead of a huge monster one. So that's my answer to the DevOps. So DevOps should be done right, of course, but I think, again, I don't have experience personally with 1,000 boxes. I have 10, 25, something like that. So, but still, when we have customers who come to us and say we have something big, we just start with, we break it down into components and have different repositories, different teams, different architects. So right now we have a customer which has 3 different projects, which in the beginning, which they work together. It's just one big piece. But we have 3 different repositories, 3 different architects, and different groups of people. And in the end, it all integrates together. So that's probably the answer. Yeah.
I want to understand the mechanics. So you're saying as the project progresses, the tickets start closing faster and faster. At the same time, if the tickets get allocated randomly, then the chance of people not knowing the background is very high. So they would still need to read those tickets to understand the background. So how does it start closing faster?
It's just back and forth. So the project is growing, the amount of problems is growing, the amount of pieces where the code needs to be written is growing, and people are, if something is not clear, people are submitting bugs very intensively, because like I said, they don't want to spend more time than they're allowed to. So if I'm an experienced developer, I get a ticket. It says 30 minutes. So I don't want to spend more than 30 minutes because I know I'm going to pay for 30 minutes. So I need to fix here, here, and here. I open these 3 pieces. If anything is not clear to me, I just abandon it for some time and say, hey, the problem is here, another ticket. The problem is there, another ticket. I create 3 tickets. I get paid for them 3, and I wait. And I wait. And then this one is closed, this one is closed, this one is closed. I get back to my original problem. Again, look at the situation. Okay, now it's better, but still not clear. I again submit a ticket. And then eventually I will get back to my original problem and fix it in 30 minutes.
And as the project goes on,
Everything is
stuff
going.
is randomly assigned.
Yeah, it's just these 3 tickets are randomly
You start
assigned.
getting more familiar with everything because it's worked on
Yeah, but the
more and more
tickets
pieces.
related.
Does the team keep getting rotated out? Or?
Yeah.
No. We don't just rotate them a lot, but we move programmers from team to team. Of course, yeah. We don't want the programmer to know.
But that was my question. Is it going faster towards the end because they've now worked on more of the project, and so they spend less time?
Well, yeah, but this is a bad thing. So if the project starts to move faster because people are becoming smarter, it's a bad thing for the project. That's the philosophy. Because people now know more than we know.
It's a bad thing that they're getting smarter. Sounds weird.
Yeah, that's exactly what's happening. So it's bad for us if people are getting smarter than us. So we want the product to be smart, not people. So if the developer opens the something and instead of saying this is bad, I'm not going to fix it because there is something refactoring is needed, he says, it's okay, I'll do it without the refactoring.
No,
He's
this
basically
isn't-
shooting
this is-
ourselves in the foot because
This is just about experience. I don't have to keep going back and reading all of the old tickets because I've already read them a couple of times. Okay.
no, it's not reading the tickets, it's reading the code. I mean,
Yeah, I don't have to go back and read the code
Yeah.
several times because I'd actually, and towards the end, I may have worked on pieces of that code already, so I'm being.
yeah, it helps a little bit, but if it helps a lot, it's a problem. If you're so experienced that you just need to open the file and immediately understand everything, even though the code is crap, that's bad. So you're basically concealing the problem.
Those are two different things, right?
But it's the
Because I
process.
understand it and it's.
If the
crap.
code is clean, anybody will understand it. No, I don't need to know to have a knowledge about the
You know,
system.
because anybody will understand it, but someone that's looking at it the first time is gonna take longer to
A
understand.
little
than
bit longer,
somebody
yeah,
that's
yeah,
been
of
there
course, yeah, a
2 or
little bit
3
longer,
times.
yeah. Sorry, there's a question there.
Can you talk about manpower and schedules? Manpower, how do you curate people? Are you looking for people with the same experience, the 20 people? Do you segment them by different experiences and skill sets? Or each of them is supposed to be able to solve the same problem that everybody else? And on the schedule side, how do you account for the fact that they work part-time? Retention, attrition,
Mhm.
and the fact that you really don't control the time that.
That's a good question, yeah. So to answer the first one about skills, right now we're mainly in Java world, so people are more or less replaceable. So they all have the same set of skills. Sometimes we have people for DevOps, like they have some specific skills, or people for like front end, like HTML or whatever.
Back end.
So that's, yeah, but in general, I think, again, my vision strategically is that projects, I mean repositories where people work together have to be designed by technology stack. So this is piece of code for Java. This is the front end. This is the something else. And then you just have people who are replaceable. So it's good for our methodology. It's good to have people who are who easy to be rotated inside the team. And the second question about the schedule and time. So right now we are the problem of speed. We're not fast. So this is our problem right now. We are trying to improve ourselves in terms of speed, but we are kind of slow because yes, we have different time zones, we have different response times. So sometimes we work, like I said, the ticket takes about 4 days, which is kind of long. To solve this problem, we have basically
You can hire us.
Right, that's what I was gonna say, why don't you have work for us instead of just hire us?
So we have just one solution, just put more people into the team. So you have 20, put 50. If 50 is not enough, put 100. In our case, there could be 1,000 people in the same repository. And then they will work quite fast, and if they don't work fast, just give them less time for each ticket. Like say, now we give them 10 days, and if the person does not complete in 10 days, we take away the ticket. So we give you 10 days, you work with it, you try to finish it. If you can't, in 10 days, done, we give it to somebody else. No matter what is your situation. If you didn't complete, if you spend already 3 hours and have something in progress, we don't care. We just take it away from you. But that's in 10 days. So if we want to make the development faster, we can say to everybody that, you know guys, now it's not 10 days, now it's 3 days. And then everybody will be like stressed too much and they will try to really deliver faster. So that's our instrument.
Can I just one small thing. I'm really excited about this idea, and I really want to participate. I think that the idea is great, but it's still, like you said, as you started, you need to develop the methodology, and I think that if you will call to companies like myself and other companies to at least to participate on the small parts and to test it, you know, and by different people, like you said, you want replaceable programmers. Try also to replace the architects and the project managers, and so the system can be developed. Not just like if you want to work on this, hire us.
That's my strategy.
Yeah,
that's my strategy. Yeah.
So you do have.
No, what's your strategy? Your strategy is hire us for now.
For now, yes.
Right,
Yes.
there's no.
It's tactics, it's not strategy.
What
It's
about
just
hire
now.
us to the -1 power? That's what I'm asking.
This is what's happening now because it generates money, it generates revenue, the company is growing, so that's okay. But the next, like in a few months, maybe end of the year, we will do what you're saying. We'll go to companies like you and say, hey guys, don't hire us. We will help you to use this
Yeah,
methodology.
of course, and you can get a share of my profit.
Yeah,
from
something like this. Yeah, I'll charge you some small amount of
Yes.
something and then help
This
you
is,
develop.
this is what I'm waiting for.
Yeah.
And whenever
That's
you're
good.
ready, I'm
Yeah, good.
good for it.
One note, you mentioned in our private conversation that you have a few open source projects that done by this methodology. Please send to me pointers on GitHub. I distribute it open repository, yes?
Okay.
So people could look on the process
Yeah.
and kind of probably
Yeah.
from experience looking
Yeah,
at
you
code.
you can find me on LinkedIn, on Facebook, on Twitter. Follow me, add me. Let's stay in touch. That's probably what I had to say in the end. Do it. I'm open for sharing more information. Yeah.
Let's five more,
Yeah.
two questions, 5 more minutes.
Two questions.
Would
Yeah.
you please comment on confidentiality and on intellectual property?
Well, yeah, we didn't discuss that. So we have a contract with programmers. So programmers give everything. The code they deliver becomes our code immediately, and then it immediately becomes the code of the customer. So we charge the customer every Monday. So we just charge the customer for everything was done during the week. So it's not like the customer is not paying us when everything is done, or is not paying us for months. It's just weekly payments for the amount of results delivered in the week. About the confidentiality, it's just programmers. So we have the contract which says, okay, you're not allowed to disclose what's going on, and we have the same contract with the customer, but that's programmers. So of course, this problem with freelancers, it does exist. So they may take everything away and publish on the internet. So, but the same can do a full-time employee. Look at this Snowden guy. What kind of confidentiality it is. Yeah.
So question, out of the 20 programmers that you have, and how many tickets are completed daily, and how many architects are reviewing the work?
If the project has 20 programmers, then approximately, I would say, like every day we complete about 8, 10, 12 tickets every day. That's the amount of tickets. Like boom,
Are
boom,
the
boom.
architects on a ticket basis also, or are they?
Yeah, everybody are tickets based. Yeah, architect is also. Architect is getting 5 minutes. We're paying for 5 minutes for the architect review. So the architect is supposed to review just what's going on in the ticket and say yes, no, yes, no. It's 5 minutes.
But the initial architect design, the skeleton.
The initial skeleton we pay like we have discussed.
Right,
For
but
the
that can be a big project too, by itself.
No, we maximum 40 hours.
But I'm just saying that the project by itself can be big, no matter, you cannot necessarily
Yeah, of
afford
course.
it in the
Yeah,
40
yeah,
hours.
yeah.
So I mean, do you break that architect project by itself into smaller tasks
No,
as
no, no,
well?
no, no.
Or
No, the skeleton is created by the architect as an unbreakable piece of work. This is just 40 hours for you, up to 40 hours. Just spend whatever you want.
Skeleton is not just architecture, it's also some code.
Yeah, exactly. It's some code, just small parts of code here and there. So the architect is supposed to create something that will show us that the solution works. If we are building a new Instagram, then it has to be a mobile app which I can download, click on the picture, and maybe, I don't know, slide it left, slide it right. That's enough. That will prove that that's something we have.
where I'm going with this is that, this is a fundamental thing, so if you start kind of with the architecture being incorrect, then the whole
Yeah,
thing is gonna
and
go south.
that's a huge cost of
You
this
know?
mistake.
And
Yeah.
then, who bears the responsibility for this kind of?
Who reviews the architects?
Well, we have two people, so one architect is creating, another one is reviewing. If they both make mistakes, that's a fault. That's it.
Architects know that they need to review the code.
We just assign them. We have project managers for us.
Another task for them?
No, we just in the same ticket. We just say, hey, architect, come in here, review it, and we'll pay you.
Got it.
Hey. So we have project managers who coordinate everything. We have 5 project managers working on this whole project. We're done. Yes,
You're
thanks
done.
for coming.
You have the 5 minutes review. So, guys, thank you. Good job.